Okay, this is finally the day that we've been waiting for. This is the fundamental theorem of calculus, which ends all of our misery and pain on finding the area all the different ways under a curve. It says if you have a function that's continuous on a closed interval, and capital F is what they're using to stand for the antiderivative, which means they've integrated the function and they have found capital F. Then the integral from a to b of f of x dx is just whatever you got when you integrated, plug in the b to it, and then minus, plug the a into it. So in other words, we can find the area of the curve now very fast by integrating f of x and then plugging in b's value into that integral minus a's value plugged into that integral. Okay, so let's do one. Finally, our shortcut. Example 1, I'm going to switch to black. Let's evaluate each definite interval. Sorry about that. It's a definite integral because it's got numbers on the integration symbol. And when we get our answer, we get a number answer instead of something plus c. We get an exact value, a definite value. So when there aren't limits of integration on the integration symbol, that was called an indefinite integral. That's what we started with. That's what you just took the quiz on. We had to do little plus c's. So here, and the three of you that were here Friday, I just realized I was going to show you that example using this rule, and I had changed my mind. So here we're going to do x squared minus 3, and we're going to do the fundamental theorem of calculus on it, which means let's just integrate it. And don't do plus c, because we're going to evaluate it from 1 to 2, which means we're going to plug 2 into it, minus, we're going to plug 1 into it. Which means we get 8/3 minus 6 minus 1/3 plus 3. Don't forget to watch your subtracting. So that is 7/3 minus 3. 7/3 minus 9/3 is negative 2/3. So isn't that nice? So nice to get an answer that fast. B part. Let's say we have something from 1 to 4 of 3 square root of x dx. Okay, we're going to rewrite it friendlier. From 1 to 4 of 3x to the 1/2 dx. That's 3 times x to the 3/2. Remember, divided by 3/2 or multiplied by, let me move that a little, multiplied by 2/3. Evaluated from 1 to 4. Maybe we clean that up just a little bit and call that 2. And it's helpful to think about x again as a root, so power over root. Now, did you realize, well, let's go ahead and plug it in. So that's 2 square root of 4 to the 3rd minus 2 square root of 1 to the 3rd. Did you know that you can choose the order that you do the power and the root? So I could have also called that 2 square root of x cubed. So we can take the square root and then cube. We don't have to cube first and then square root. So it's easier to do the square root of 4 to get 2, and then 2 cubed is 8. But 4 cubed is 64, square root of 64 is 8. So, but sometimes it matters. Cube root of 1 is 1, square root of 1 is 1. So 16 minus 2 is 14. All right, let's do one with trig. We've got the integral from 0 to pi over 4 of secant squared x dx. The integral of secant squared x is tangent x, evaluated from 0 to pi over 4. So first you plug in b always, the top value first, minus bottom value. You might remember that pi over 4 is that 45, which is square root of 2 over 2, square root of 2 over 2, and cosine sine. Tangent is sine over cosine, so y over x, same thing over itself, is just a 1. And if we think about the ordered pair at 0, that's the point 0, 1. So sine over cosine is 0, and you get 1. You don't have to do unit circle to figure that out. Just make sure you're in radian mode and plug it in. All right, so I think we all agree that this fundamental theorem of calculus is a very nice thing. Last example, I'm skipping example 2. We'll look at example 3. It says, find the area of the region bounded by y equals 2x squared minus 3x plus 2. The x-axis, x equals 0 and x equals 2. Oh gosh, Ms. Stewart, I thought you just said we didn't have to do area this way anymore. So that's a parabola like this. X equals 0. Oh, I didn't draw that very well. So if x is 0, y is 2. X is 2. Y is 4. Sorry, my brain's so tired. So it looks like this. So we're talking about this between 0 and 2. Talking about this area. But we don't have to find area that way. This problem can be written as a definite integral from 0 to 2 of our function. And all we have to do is integrate it and plug in the 2 and the 0. So it's 2x to the third over 3 minus 3x squared over 2 plus 2x, evaluated from 0 to 2. So plug in a 2, 8 times 2 is 16 thirds, minus 4 times 3 is 12 over 2, which is 6, plus 2 times 2, minus, plug a 0 into all that, 0 and 0 and 0, and you get negative 2, which is negative 6 thirds, so I think you get 10 thirds as your area. So nice. I hope you all enjoy your homework on that. It's a good review and practice of integrating, and now you get to do the definite integral. All right, try it, and I'll see you Wednesday.